This is our lesson 5 part 3, and I will try to explain the solution with a flowchart for the problem that we described in part 2, which was the 9 balls that look the same, but one of them weighs a little bit more than the rest. 8 are equal in weight and 1 is heavier. So how can we print the number of the ball that's heavier? We mark the balls from 1 through 9. So this is how it looks with a flowchart. I hope you can see that. I can make it a little bigger. Okay, let's look at it step by step. So the first step is start. We said we always start from here. This is the start of the flowchart or algorithm, and this is a rectangle, so there is an instruction in the rectangle. The instruction says put balls 1, 2, 3 on the left, meaning put 1, 2, 3 together in the bucket on the left side of the scale, and put 4, 5, 6, that has to be on the right, of course. So now we look at the scale and we ask a question. Is the scale balanced? If the scale is balanced, that means the side where 1, 2, 3 is equal in weight to the side where 4, 5, 6 is, because we put 1, 2, 3 on the left and 4, 5, 6 on the right. So if the scale tells us that they are equal, then that means that the heavier ball is 1 out of 7, 8, or 9, right? This is our conclusion, as we said before. So if the answer is yes to this question, if the scale is balanced, then we take ball number 7 and put it on the left side of the scale, and put ball number 8 on the right side of the scale. So now we're checking balls 7, 8, 9. And we ask again, is the scale balanced? If the scale is balanced, that means 7 weighs the same as 8, because we put 7 on one bucket and 8 in the other bucket. So if they are equal, that means the only one that's left is 9, and therefore we print, you see this kind of thing is print number 9. Now, if they were not balanced here, then we go into this branch, which is no. It says no. Here it has to say yes. So if it was yes, then we concluded that 9 was the heavier and we printed it. If the answer is no, then we have to ask another question. No means one of them pulled down, because we put 7 and 8, remember? So then we ask, is the left side down? And on the left we put number 7. If the left side is down, the answer is yes. That means 7 is the heavier, right? And if the answer is no, that means the right side is down, because if we got through here, that means they are not balanced. So one of them has to be down, either the right or the left. So if the left is not down, which means we go here, then that means the right is down, and on the right we had ball number 8. So then we print 8. So here, this side solved the problem for 9, 7, and 8. And we only weighed the balls twice, right? So this answers our question. So this is this branch. But now let's go to the other branch. What happens in the beginning after the first weighing of 1, 2, 3 versus 4, 5, 6 if the scale is not balanced. This was this branch. And now we go to the case where it's not balanced. So if 1, 2, and 3 are not equal in weight to 4, 5, and 6, that means one of them pulls down, either the left side or the right side. So then we ask another question. Is the left side down? On the left we have 1, 2, 3. If the answer is yes, we go here. If the answer is yes, that means 1, 2, and 3 contain the heavier ball, because the 1, 2, 3 pull down. So then we weight the balls 1 and 2. We put ball number 1 on the left and ball number 2 on the right side of the scale. And this is the second weighing, right? And then we asked if the scale is balanced. And we go through the same principle as we did in this branch. If the scale was balanced, that means 3 is the heavier, because 1 and 2 are equal in weight. Then that must leave 3 as the heavier. So if the answer to the scale is balanced question is yes, we go here and we print 3. If the answer is no, then we have to ask which side is down. If the left side is down, we add ball number 1 on the left. So if the answer is yes, that means ball number 1 has to be printed, because that pulled down, and that means that 1 is heavier. And if the answer is no, that means the right side pulled down, and on the right side we put ball number 2. So then we print 2. So we solved the problem for 3, 1, and 2. We printed the correct ball that's heavier according to the questions that we asked and according to the 2 times that we put it on a scale. Now there is one left, which I left you as homework actually. And this is when we go here and we say that after the answer to the first question, if the scale is balanced, the answer was no, and then the answer to is the left side down was also no. So if it's not balanced and the left side is not down, then the only remaining option is the right side is down. So now I want you to proceed from this branch and fill out the same kind of idea that I did here and here, but now you'll have the balls that are not 1, 2, 3, not 7, 8, 9, but you have the 4, 5, 6, because those were on the right, and if we got here, that means the heavier ball is 1 out of 4, 5, or 6. So try to look at what I did, review it again, and once you finish, try to complete the chart and solve it for 4, 5, 6 in the same manner that I solved it for 7, 8, 9, and 1, 2, 3. And then you'll add another branch here. And once you finish with that, pay attention that I put, every time I put a connector, every time I print, I go to the connector, print, go to the connector, and then I connect the connectors. Again here, print, go to the connector, print, go to the connector, print, go to the connector, connect the connector to the other connector, and this connector to this connector. And the reason we do that is because we want to end the flowchart with one end statement, which will be the same shape as the start, but all the way at the bottom, and all the connectors at the end will go into the end. So once you finish this, we'll do the complete flowchart, which will solve the algorithm with 2 times putting them on a scale and concluding which out of the 9 balls is the heavier one.